I am Samitinjay S. Bansode from JSPM and TSSM Group of Institute, Pune. I welcome you in the Transportation Engineering Laboratory Practical Series. So today we are going to see the Los Angeles abrasion value test on the aggregate. Our aim is to determine the Los Angeles abrasion value of the aggregate. So what happens while using this aggregate in the road pavement or in the runway? At that time, what will happen due to the continuous impact loading on the crushing loading, the edges of the particle that may get eroded, so that there is a formation of powder or erosion of the aggregate will be there. So we have to find out this erosion, how much percentage of erosion is there. So by calculating the erosion, we can decide whether this aggregate they are suitable in the road pavement or the not. So for this purpose, for finding out the abrasion value, so we need the sieve size as per the grade sample of A, B, C, D, E, F, G. It has been classified in the IS 2386 part 4. So as per the IS 2386 part 4, we have to find out the Los Angeles abrasion value. So this is the sieve which will just definite the differentiating weight of the aggregate sample which are in the abrasion. So the equipment are the Los Angeles abrasion machine with the abrasive charge or the balls for this purpose, and we also need the oven. So the aggregate which has been taken as per the grade of the sample, that should be placed in the oven for 4 to 6 hours at 105 to 1010 degrees centigrade. Now we will see what will be the grading of the state sample and the abrasive charge that should be placed in the Los Angeles abrasion machine. So here we can see the sieve size having the square holes passing through and retain on. So it has been starting from the 80 to the 2.36 80 passing 63 retained, 63 passing 50 retained. Likewise we have to select the proper sieve with the A, B, C, D, E, F and G. These are the different grades that we are going to use for the sample. So if you consider the A grade, so A grade is having 40 passing 25 retain is the 1250 grams, 25 passing 20 retain is 1250 grams, 20 passing 12.5 retain is the 1250 grams, and 12.5 to 10 retain is the 1250 grams. So likewise we can also take the B sample, so B grade, C grade, D grade, E grade, F grade and G grade depending on our necessity, means whether we are going to that kind of the aggregate, use of that aggregate. So in base course, in sub base course or in soling, so we have to consider all the parts of that aggregate or use of that aggregate depending on this grading. So let the example, we will have selected one A grade. A grade sample is having 40, 25, 25, 40. So 1250 grams of each and every size of the aggregate. So if we consider the A sample, so for the grading A, we required nearly about 12 abrasive charge. This abrasive charge is around weight of 5000 grams plus minus 25 grams. So now for the consideration of the practical, I have selected the F grade. So for F grade, we can select two sieves, that is 50 passing and 40 retain, and 5 kg of weight sample we have to take. So for the F grade, we have to use the 12 abrasive charge or 12 spears in the Los Angeles abrasion machine as an abrasive charge. So I have put the aggregate in the oven. So we'll just remove all the aggregate. We have to take the precautions. So we have to wear the gloves, cotton gloves, to remove the aggregate from the oven because it's too hot. So this is the Los Angeles abrasion testing machine. So the drum, this is the drum, and we are having the cover plate. We have to remove the cover plate for just placing the aggregate inside that. If you see the machine from inside, so it is elevated. So this is the cover plate which I have just drawn. we can see the baffle wall. We can call it as baffle wall, or we can call it as a steel shelf is there. At the time of rotating, it will come upwards, and simultaneously all the material that will be passing at this place, and at this place there is a formation of abrasion, because we are going to place the steel balls or abrasive charge inside this machine. So this abrasive charge that will be abruptly placed on the aggregate, so there is a formation of abrasion on the aggregate. Just give the 500 rotations. So for counting the rotations, we are having this counter. So on this counter we have to find out the number of rotations. Now I am placing the aggregate. I have took the weight of aggregate as a 5 kg, as the aggregate they are passing on 50 mm ISU and written on 40 mm ISU. So if you count the number of balls, these are the 12 balls. This has been placed in the placed, and also the aggregate we have placed of 5 kg. The abrasive charge is also around the weight of 5 kg, so equal weight of aggregate and abrasive charge it has been placed. Pouring all the material means aggregate and abrasive charge, we are placing cover plate in the position, and we have to fix this cover plate with the help of the nut and bolt arrangement which is provided on the machine. Now we will start the machine. Just I have removed the aggregate from the Los Angeles abrasion testing machine. I got this much dust, and this aggregate it has been sieved to the IS 1.7 mm sieve. So after sieving this, I got this much dust. Now this, if you observe this aggregate are having some dust particles on this. So I have to thoroughly wash this aggregate in water sample, and that water it will be dust and water that will be kept in the oven for 4 to 6 hours at 105 to 110 degrees centigrade. To after evaporating complete water, we will get the complete dust which is containing in this machine. I got this much of fines which are present in the aggregate after washing, and this much are the fines which are collected at the time of sieving. So we will weight these together. So I got 0.494 kgs. It means that 495 grams of the fines which has been passing from the 1.7 mm ISU. This 495 grams is the weight of all fines which are passing the 1.7 mm ISU, excluding the weight of beaker, and total weight we have taken was the 5000 grams. Value is nearly about 9.90%. So this is the chart which showing us the suitability of aggregate for the abrasion. So if we are having the WBM with subsurface force, the limiting value is 60%. Then BBM and bituminous surface force, the value is of 50%. WBM surface force value is 40%. Bituminous penetration macadam, so value is 40%. So bituminous surface with the dressing, then value is 40%. Cement concrete surface force, the value is only 35%, and for the bituminous concrete surfaces, the value is only 30%. So if you take the value of this bituminous penetration macadam and the WBM surface force, so it is coming 60% and the 40%. Total results, they are very much larger than the results which we got here, that is the 9.97%. So we can say that the aggregate are suitable in every course of the layer. But as we have taken the size of aggregate which are passing from the 50 mm and retain on the 40 mm, so that kind of the aggregate we are going to use in the WBM courses. So for WBM, if you take the both the values, it is of 60% or the 40%. So our aggregate, they are suitable for any kind of the WBM surface course and also for the subsurface course. Okay, thank you.